So here is a discussion of piecewise functions. Now, in very simple terms, a piecewise function is simply, here's function f of x, but it has two different definitions based on the domain. Namely, if x is less than 0, then f of x is 2x. If x is greater than or equal to 0, then f of x is negative 2x. Notice how much the graph of this looks like the absolute value function. And you can think of the absolute value function quite easily as a piecewise function. So the first thing we're asked to do is evaluate some various values for x. So f of negative 1. Well, negative 1 is less than 0, so negative 1 times 2 is negative 2. So we can see when x is negative 1, y is negative 2, or f of x. F of 0. Now, when 0 is part of the domain for negative 2x, so it is defined, and so it's going to be negative 2 times 0, or 0. F of 3, okay, well, 3 is greater than or equal to 0, so it'll be negative 2 times 3, which is negative 6. So you go x is 3, and then here's negative 6. So now, and here's the graph, okay? Nothing too mysterious about how the graph is working here. All right, now let's answer these questions here. Using interval notation, answer the following questions. Where is f of x increasing? Increasing means a positive slope. Positive slope means as you go from left to right, y is going up. So as x goes from left to right, is y going up. Okay, well, here, let me get ready so I can use my pen here. Start inking. Okay, so you can see here's the positive slope. So from x comes from negative infinity and approaches 0, then that's where f of x is increasing. So f of x is increasing from negative infinity to 0. Now we use parentheses. That means negative infinity and 0 are not included in the interval of x in which f of x is increasing. Now there's a couple of reasons for that, but let's just say we will always use parentheses for increasing or decreasing intervals. Always use parentheses for increasing or decreasing intervals. Now there's some very specific technical reasons for this. The main reason of which is the slope of the maximum of an increasing or decreasing interval is always 0. Now you'll learn why later on in the course, but for now you just have to take my word for it. So in other words, the slope of 0 is 0 in this instance right here. Okay, why? Because it's the maximum of the interval of where it's increasing, or decreasing for that matter. So later on you'll learn why. But anyway, just to keep it simple and safe for you, always use parentheses. We're describing increasing or decreasing intervals. Now that's not the case where it's always positive or whatever. Now where is f of x positive? Nowhere. And where is f of x negative? Again, we're talking about an interval of x. So from negative infinity to positive infinity, f of x is negative. So from where x equals negative infinity to where x equals positive infinity, the graph of f of x, or in other words f of x, which is the graph, is always negative. Okay? Is it continuous? Yes. Okay, that is, there are no gaps in the y values. No gaps in the y values. So f of x is continuous. So you could take a pencil and there would be no gaps wherever you're drawing the graph. Okay? Identify the following limits. The limit as x approaches 0 from the positive side. What does that mean? So here's x. That means x is coming from the right, going to the left. It's approaching 0 from the positive side. Okay, so here's x. What's f of x approaching? So here's f of x. As x approaches 0, what's f of x doing? It's approaching 0. Okay, it is also approaching 0. Okay? Now, what's the limit as x approaches 0 from the negative side? That's how you read that, from the negative side. Well, I'm coming from the negative side. I'm approaching 0. Okay? Coming from the negative side, approaching 0 on the x-axis. What's the y-axis? What's y doing? What's the f of x doing? It's approaching 0 also. So, does f of x have a limit as it approaches 0? Yes. And in order to have a limit, it must be the same from both sides. Okay? So in order for f of x to have a limit at 0, it must be the same coming from the positive side and the same coming from the negative side. And it does. So it does have a limit, and that limit is 0. So the limit of f of x as x approaches 0 is 0. Okay, next. Oh, by the way, I wanted to show you something here about graphing this. You want to check your graph, right? Okay, so let's go here. I got the calculator here. Let's recall how to graph piecewise functions on the calculators. I'm going to y equals. Now if you graph piecewise functions, that means they have a limited domain. So you're going to include the domain along with the definition of the function. So it'll be open parenthesis 2x close parenthesis open parenthesis. Now we'll put x, and then we're going to hit second and math, and then I'm going to hit less than 5 less than 0. Okay, close parenthesis, and double check. Let me double check. F of x equals 2x when x is less than 0. I hit enter, and it equals, the next one will be negative 2x. Oops, I forgot the parenthesis. Open parenthesis, negative 2x, close parenthesis, open parenthesis. X is greater than or equal to 0. So I hit greater than, second, math, greater than or equal to, that's 4, close parenthesis. Okay, let's double check. 2x, x is less than 0. Negative 2x, x is greater than or equal to 0. And look at that, I forgot the 0. Man, I'm forgetting everything today. Okay, so let's hit graph. And I want to use the standard window. So I'm going to hit zoom and then standard 6. Okay. And there we go. Okay. That looks like what we drew, so everything is fine and dandy. All right. On to the next function. Okay. So f of x is negative x plus 3 if x is less than 2. And 2x minus 3 if x is greater than or equal to 2. So f of negative 1, we're going to plug in negative 1 into negative x plus 3 because negative 1 is less than 2, and we get 4. So f of negative 1 is 4. F of 2, now 2 is included in 2x minus 3 because 2 is not x is less than 2, so that's not part of the solution of part of the domain of negative x plus 3. 2 is part of the domain for 2x minus 3, so it would be 6 minus 3 is 3. Okay. Let's see, we did negative 1, 2, we do 2, and then 3. All right, so we did 2, 4 minus 3 is 1, and then 3. 2 times 3 is 6, minus 3 is 3. Okay. So we did that. Now we make the graph. Okay. So how do I make this graph? Well, the other ones are pretty easy. You got, the key point is 2 for both of them, all right? So you got negative x plus 3. So plug in 2. This is 2x minus 3. Let's do negative x minus 3. So let's plug in 2. So we got negative 2 minus 3. All right? Which is negative x. Negative 2 plus 3. Let me start this over again. Okay, so it's going to put into negative 2 plus 3. That's the first function. Okay, so that equals 1. All right? So this point is going to have an open circle at 1. And then it's doing negative x at y equals 1. So we have this point here, 2, comma 1, right here, 2, comma 1. And then the slope is negative x, so we can just go from this point in the negative x direction. So negative x. Now, let 1 to the left and up 1, 1 to the left and up 1. And notice we cross the y-axis at 3, which is the y-intercept. And then I just continue. 1 to the left and up, 1 to the left and up, 1 to the left and up, and so on. Okay, so that takes care of the negative x plus 3. Now, 2x plus 3 does have 2 as part of its domain, so I make a little solid circle here. And now I'm going to go, now notice, if I keep going down from here with a slope of 2, I'm going to go down 2 and then down 2 more, and there's the y-intercept of negative 3. So I'm now on the right track. I'm going to go 1 to the right and up 2, 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 and there's that slope of 2. So now I've got both branches of this piecewise function drawn. I've defined the numbers in there that I wanted to do. And so let's answer the questions out here. Now we can do this, let's do it really quick on the calculator also. If you feel like you got this and you can skip this, otherwise you can practice a little more. Now the functions are going to get a little bit more complicated. So anyway, so I'm going to put in parenthesis, negative x plus 3, close parenthesis, open parenthesis, x, second math, greater than, or less than, it's less than 5, it's less than 2. I put in 2, close parenthesis, let's check it. Negative x plus 3, x is less than 2. Enter. Okay, open parenthesis. 2x minus 3, close parenthesis, open parenthesis, x, second math, greater than or equal to, that's 4, greater than or equal to 2, close parenthesis. Let's double check. Negative x plus 3, x is less than 2, 2x minus 3x is greater than or equal to 2, and let's graph it. Okay, and that's pretty much what we had. Now if we want, and you can see that's what we got on our paper here. It doesn't quite look like the paper because our paper looks a little bit more square. If I hit zoom and then square, it's going to look a little bit more like what we did. Okay, all right. Now let's work on these limits here. And where it's okay. So where is f of x increasing? Well, it's increasing at 2 comma infinity. So you go to where x equals 2, and then x goes on to infinity. In this interval from 2 to infinity, f of x, or the graph, is increasing. Okay, where is it decreasing? Well, from where x is negative infinity up until 2, it's decreasing. Is it continuous? Yes. There are no gaps in the graph. Where is f of x positive? Well, it's positive from where x equals negative infinity to where x equals positive infinity. It's always positive. Where is f of x negative? Never. Identify the following limits. I got to go down one more thing here. Got all the limits here. Okay, so the limit as x approaches 2 from the positive side. So here's x approaching 2 from the positive side. What's the limit? It's 2. Yeah. F of x is approaching 1. Okay. Now, as x is approaching 2 from the negative side, what's f of x approaching? It's also approaching 1. So the limit of f of x as it approaches 2 from the right side and the left side, from the positive and negative side, is the same, 1. Therefore, f of x has a limit as it approaches 2, and that limit is 1. 3. Okay. Now, this is kind of hard to visualize on this paper because it's kind of cramped. This is one place where the working with the calculator will help us a little bit. So we got x squared if x is greater than or equal to negative 1. So this isn't too hard to figure out. Okay, you got x squared, so the vertex is going to be 0, 0, right? And then you know that at negative 1, it's going to be 1. If x is negative 1, y will be 1. So we got that little hook there, and then 1, and then 4, and then 9, and so on. Okay. Now, if x is less than negative 1, then the graph is x plus 1. So let's take, now the key point is negative 1. So let's take x plus 1. Okay, that's f of x. Now the key point is negative 1, so let's plug in negative 1. So negative 1 plus 1, okay, equals 0. All right, so we're going to have an open circle. Now you can't see it. It's really hard to show on the paper here, but that should be an open circle for this graph at negative 1. Okay, so we have this point, negative 1 comma 0, but it's not actually part of the graph, so there should be an open circle there. But if I draw the open circle in it, it kind of bumps into the graph. So and so then I'm going down at a slope of, you can see it, negative 1, negative 1, negative 1. I'm sorry, positive 1, down 1 and over 1, down 1 and over 1. It's positive 1 all the way. And if I continued into the y-intercept, you see the y-intercept would be 1. Okay, but the graph stops at negative 1. Now let's graph this guy, because it'll kind of help us out here to figure out what's happening. So I'm going to put in x squared. Oops, again I forgot the. So we're going to do x squared, and then x is greater than or equal to negative 1, close parenthesis. Okay, x squared equal to negative 1. Okay, and then it's open parenthesis, x plus 1, close parenthesis, open parenthesis, x is less than negative 1, close parenthesis. Okay, x plus 1, x is like 1, etc., etc. Now, let's look at our window, and let's really narrow down our window here. Let's do negative 2 to 0.5. Let's do negative 2 and 0.5. Okay, we just want to see this area right around here. Okay, that's all we really care about. So let me hit graph. Okay, so there's the button hook. All right. So here's x squared ending at negative 1, okay, including negative 1. Okay, so we have this point here, it does exist. Negative 1, see, notice 0.5, negative 1, comma 1. Okay, and then here's x plus 1 at ending at short of negative 1, x equals negative 1. Okay, so this point right here, there would be a circle here. If the graphing calculator could do it, it would put an open circle here. It would have a solid circle here. Okay, so there's our graph. Now, f of negative 3, that's definitely in the range of x plus 1, so that's negative 3 plus 1, negative 2. F of negative 1, okay, that's in the domain of x squared. So that's going to be negative 1 squared, which is going to be 1. And 4, obviously, is in the domain of x squared. So that'll be 4 squared. That'll be, 16. Okay. Now, let's answer some questions. Let's answer these questions here. Okay. All right. Using interval notation. Okay, where is f of x increasing? Okay. From negative infinity to negative 1, we have a positive slope. Okay, it's increasing. All right. Or it's increasing from 0 to positive. So as x approaches positive infinity, y is increasing. Okay? So here, as x comes from negative infinity and approaches negative 1, the graph is increasing, f of x is increasing, or y, or the graph. You can think of all of these as the same, y, or f of x, or the graph, the actual graph itself. They're all